Okay, thank you very much for today. I kindly want us to look at how we'll be able to use the Taylor series to, prove a certain question. Now, it's just simple, okay? It is like we have a mathematical function that is 3x squared. Now, in this function, we want it to pass through a certain stages. And after going through that stages, if it doesn't change, that means that that function is said to be a function that the Taylor function cannot even change it at all. Do you get it? That is all. Now the idea here is this. You've been given a function like 3x squared, and so using the Taylor series to check if it leaves it what unchanged. What is the Taylor series? It's a function, a very long function. So this is what we are going to do. First of all, list all the orders of derivative in the function excluding 0. That means that the function being given to you, we are going to differentiate it to the last time excluding what is 0. Are you getting it? So this is the function itself, that is 3x squared. And now this is its first differentiation, that is giving us 6x. So we are going to get that. And this is its second differentiation. You are going to get what? 6. So if it has another value of x, you have to continue differentiating what your values. You may ask what the meaning of this. We will get to it. Okay. Now, in our function, let x be equal to what? X0. So wherever we are going to see x, we are just going to replace it by what? X0 here. So note this very carefully. One mistake, one omitting of this 0 will render your answer wrong. Do you get it? Now, that is why we have 3x squared, but we've changed it to what? 3x0 squared. We have 6x here. We've changed it to what? 6x0. And there's no s, so it maintains as it is. Now, this is the general Taylor's formula. It is giving us f of x0 multiplying x minus x0 raised to the power 0 all over what? 0 factorial. Now this is f of x. That means the function itself, that is the original function. But we are going to remove the x and replace it by x0. That is why you are seeing f of what? X0, which is this function. Do you get it? Now plus f prime of x0 all over 1 factorial multiplying x minus. So this is a constant function that it has to multiply all of them. But the higher you go, the higher the value, the order. Do you get it? The degree. So the degree will be changing. Here it is 0. So here to the degree will be 0. But remember, it is just x minus x0 raised to the power 0. So when you come here, the same x minus x0 raised to the power 1. When you go to the next one, x minus x0 raised to the power 2. So it continues. It doesn't what? It doesn't change. And so it depends on the level of your factorial. You call this factorial. Okay? And now we have f prime. That means your first differential multiplying x minus x0 raised to the power what? 1 all over 1 factorial plus f prime prime of x0. Do you get it? Multiplying x minus x0 raised to the power 2 all over 2 factorial. Okay, now let's go. Substitute the differential values. So this is the differential values. Here we have what? 3x squared. That is our original function. And that is what it says. So we come and substitute here. That is 3x0 squared. Note this very carefully. Multiplying x minus what? X0. They divided by 0 factorial plus 6x. That is this 6x, which is the first prime. Then it is here. That is 6x0 all over 1 factorial multiplying x minus x0 factorial plus 6 all over 2 factorial multiplying by x minus x0 raised to the power 2. So this is the general function. You put in the values, you are done. Now from here, edu mathematics. Inti edu hanon kwa de minua. You can continue by just solving and dividing. That is all. But be very careful with your multiplications and addition, especially this kind of expansions. Be very careful. Look at what we are going to do. We have here. This is 0 factorial is 1. Okay? And x minus x0 raised to the power 0 will also be 1. So we are still going to maintain 3x0 squared plus. Now this is 6x. This one is also 1. So 6x will come multiplying by x minus x what? 0 plus. This is 6. This is 2 factorial. This 2 factorial is going to be 2 times 1, which is still 2. That means if you have 3 factorial, the answer is not going to be 3. The answer is going to be 3 times 2 times 1. That is going to give you what? 6. If you have 4 factorial, it's going to be 4 times 3 times 2 times 1. That is how it continues to go on. So this is 2 factorial, so it is 2 times 1, giving you what? Just 2. And when you divide 2 by 3, you are going 2 by 6, you are going to get what? 3. Then you have your bracket here. Then when we expand this, note this very carefully. We are going to use x minus x0 multiplying another x minus x0, which when you expand, you are going to get x squared minus 2x x0 plus x0 squared. Okay, let's expand what is here too. We are going to get 3x0 squared plus 6 multiplying by 6x0 multiplying by 6 multiplying by x is going to give you 6x x0 minus this 6x 0 multiplied by this one is also going to give you 6x0 squared plus 3 multiplied by x is going to give you 3x minus 3 multiplied by 2x x0 giving you 6x x0 plus 3 multiplied by x, so you are going to get what is here. So when we simplify, this minus 6x0 is going to cancel this positive 6x0. Now when we come here, we are going to get 3s squared. Here too is what? 3s squared, which when we look at it very well, we are going to have 3x0 squared plus 3x0, which is giving us 6x0 squared, so that it will be able to cancel this minus 6x0 squared. So when this 6x0 squared is able to cancel minus 6x0 squared, your final answer is what? 3s squared. So we are going to have 3s squared. Therefore, the Taylor series leaves the function what? Unchanged. So you can see our function was f of x is equal to 3s squared. After 3s squared going through a lot of stages, it's still 3s squared. So this is what we call the Taylor series. If you don't understand anything, you can just WhatsApp me and I'll give you a brief understanding, a brief introduction to it. From this video, I'll quickly send the Maclaurin series also. Thank you very much, and my name is Mr. Henson.